Now let's look at the next type of reaction. This is called an addition reaction. One important thing to keep straight is which families do which type of reactions. So we covered the substitution reactions. Remember, that's the alkanes and benzene, the aromatics, that do the substitution reactions. As we move into the addition reaction, these are the unsaturated molecules. So these are the alkenes and the alkynes that are going to be doing this type of reaction. And there usually needs to be some form of a catalyst present in order to make this happen. Again, you don't need to know what those catalysts are or be able to figure them out. Just know that they're quite often listed as something over the reaction arrow. I probably won't draw them in the examples, but they may be present in questions and things that you see. All right. And the last part is, if you look at D in your notes, it says there's hydrogenation, hydrohalogenation, hydrohalogenation, and hydration. You don't need to know those terms. All it means there is it all depends on what you're adding. So the hydrogenation just means we're adding a hydrogen. The halogenation means we're adding a halogen molecule. The hydrohalogenation just means something like HCl, a hydrogen and a halogen that are combined. And the hydration would be an HOH, a water molecule. So don't worry about the terms. I'm not going to test you on whether you know the terms. Just know that it's one of these kind of small molecules that's going to be added on to these. So let me give you an example. If we start with a ethene molecule, and let's do hydrogenation first. What's going to happen here is each of these H's gets added separately, one on each side of the double bond. So this H, let's say, goes here, and this H goes here. And in order to attach those H's, we have to break a bond to free up some bonding electrons. So one of the double bond is broken in that process. And what you end up with is now an ethane molecule. So we broke the double bond, we added some extra hydrogens on there, and now we have a less saturated, in this case a more saturated, in this case completely saturated molecule. If you did this to a triple bond, it would go from being a triple bond on one side to a double bond on the other side. Okay. The same thing would occur if we did ethene and added in a halogen, like a chlorine. Except now you would get your ethane, right? We've still broken the double bond to attach, but you'd get a chlorine on both of these, a dichloro, a 1,2-dichloroethane. And that's important to remember, that the two chlorines can't be like this. They can't be on the same, like this right here. They can't be on the same carbon. That wouldn't cause a break of the double bond. They have to be one on each side, right? One on this carbon right here and one on this carbon right here. Otherwise, it's not going to work. So just keep that in mind. Yeah, let's go on to some other examples. So if you have an ethene, and we do the hydrohalogenation, the same thing's going to happen. The H will go to one, the chlorine will go to the other, and so we'll end up with ethane, and the H ends up here, and the chlorine ends up there. Now you don't have to show that H necessarily, but I show it just to so you can kind of see what's going on here. And if it was an ethane reacting with a water molecule, then you would end up with an alcohol in the end, right? There's the H, there's the OH, and we've created an alcohol. But the important thing is here, you start with two molecules as reactants. You end up with typically just the one as a product, and we've become more saturated. We went from a double bond here to a carbon-carbon single bond. That's kind of the defining characteristic of an addition reaction. Now, the last thing I want to show you is just the idea that there can be multiple possible products here. So let's say I started with something like a pent two ene like this. Oops, not there. Something like that. And if we combine that with an HCl molecule like that, well, there's two possibilities here. That this hydrogen could go here, and the chlorine could go here. That would give me a 2-chloro. Or the other option would be that the H could have gone here, and the chlorine could have gone there. That would give me a 3-chloro. So sometimes, just like we did with the substitution reactions, sometimes you're going to have to list more than one possible product. So here we would say there could be a, let's do the green first. So that would be a 2-chloro. Fill in our H's here. Or it could have been a 3-chloro, like that. And you don't have to worry about the conditions or which one of those maybe would be more likely to happen. Let me get out of the way there. Which one is more likely? You just need to know that that's a possibility, that either of those outcomes could happen. And just watch out for that, and that's it. So that's the addition reactions. Remember, they're the alkenes and the alkynes. If there's anything there that doesn't make sense to you, make sure you reach out. And otherwise, hopefully it all makes sense.